I think the biggest disability that we have as human beings is unbelief. Everything starts with a vision, and a man without vision dies.
Hi and welcome back. In this video I wanted to talk about a really important concept in programming, which is mutability. Some things in Python are mutable and some things are immutable. So what is mutable? A mutable piece of data is one that you can change after you've created it. An immutable piece of data is one you cannot change. Now, here you may be wondering, aren't all pieces of data mutable? Like when you create a variable, you can then change it? Yes, that is true. However, the variable itself is not the piece of data. Let's go back to our dictionary that has how long ago we saw some of our friends. Here, the data is the dictionary. So Python creates this dictionary, and then the variable is essentially like a post-it note that's been attached to the variable to the data that says this piece of data now has this name. However, when you do something like another variable equal friends last seen, these two are the same dictionary. Once again, what we've done is we've attached another name to the value in here, this dictionary here. This is a really important concept in programming. Let's forget about this name tagging for just a moment, and I'll ask you, how do you know it's mutable? Well, whenever we create a new dictionary, it's stored physically in your computer's RAM, random access memory, which is a type of memory that only lives while the computer is on and your app is running. As soon as your app terminates, your program finishes, i.e. if we run this and it reaches the end, the RAM does get lost, or rather the memory that was assigned to this Python program gets lost, and then it can get overwritten by other programs. Python can give us the ID of the object. The ID function here is used to give us the ID of any object, and in this case we're passing it the friends last seen variable here, which points to this dictionary. So it can give us the ID of that, and in the majority of Python implementations, that's an interesting concept by itself, but in your Python implementation, the one you'll be running most likely, and certainly here in REPL it, the ID is the address of the object in memory, and that's precisely the first cell in a group of cells in your RAM which stores your object. This ID function here gives you the first cell in the group. That's because the object can take up multiple cells, and they normally do. Okay, so let's run this program. And now you get a number. Seemingly arbitrary number, but when we run the program again, notice that we get a slightly different number. It wasn't so easy to see, but trust me, it's a different number. Now, when we say friends last seen is now this dictionary, which looks the same, but is an entirely new dictionary, and you can tell that by, once again, calling the friends last seen function, the ID. Notice how these two numbers are very slightly different. That's because these objects are not the same object. They are two objects which have the same content. Think, for example, of two cars coming out of a production line. They both have four wheels, a steering wheel, they both may be red, they both be the same make and model, but they are not the same car. Same thing here. We have a variable which has a name, and that is assigned to this dictionary here, this particular object. And then we get the ID of it. Then we assign it to another dictionary which looks the same and get the ID of it. And those two dictionaries are created one after another. The reason why this dictionary cannot have the same ID as this one is that when the time this is created and the time this is created, this one still exists. So it cannot possibly appear in the same place. The other one's taking up the space. Okay. So even though the dictionaries have the same values, their ID values are different. New dictionaries were created each time. And hence their memory addresses, what the ID function returns, are different. However, what if we do this? We create a new dictionary here, which has an entirely new ID, and then we say friends last seen, Rolf is now 0. What do we think this is going to print? Is it going to print an entirely new ID, or will it print the same ID as before? Well, it doesn't really matter what you guessed, but what matters is that the ID will be the same. And as you can see, these last two numbers here are identical. That's because when we run this line of code, we have modified this object. We have not created a new object, we have mutated it. This is a mutable data structure, the dictionary. Okay. This is the case with many things in Python. When you create your own classes and you change a property of your objects, you're not creating new objects, you're just changing something that is already there. However, there are a few immutable things in Python. Integers, for example, are immutable. Let's say that you get myInt, and that's 5, and then you say id or print id of myInt. When we run this, we'll get an ID for our integer object. But how can we modify the 5? You cannot change 5. 5 is always 5. If you make it 6, that's an entirely new thing, an entirely different thing. So, indeed, if you do myInt is equal to myInt plus 1, and then you print the ID of myInt, that's going to be an entirely different value. And as you can see here, it's pretty similar, but it's not quite the same one. So integers are an example of something that is immutable. You cannot change it, because 5 is always 5. Other things that are immutable are floats, strings, and tuples. You cannot change tuples, for example. Okay. Lists, however, are mutable, and I'm going to show you an example. Let's have a friends list, Rolf and Jose. Then we can print the ID of friends. We can then do something like append, and then we can print the ID of friends again. And now notice how these two will have the same ID. We've got 5 values here, so we'll now get 7, and these two down here have the same ID exactly. We've changed or mutated the list, we have not created a new list. When you use list comprehension, for example, a new list is created. So these are the immutable types in Python. Integers, floats, strings, tuples. And there's not many more. In fact, I don't know any other immutable types. So what is really happening when we mutate an object? Maybe you can see a pattern here, which is that we've got a mutable type, and then here, but this is our mutable type in this case, the dictionary, and then here we're mutating it. So what's happening here on the innards of Python? Well, this is happening. Friends.scene, set item. A function is happening. A function call is occurring. This function call here, that takes in self as an argument, is modifying the self object. It is not creating a new dictionary, which you would do with, like, creating a new dictionary. You'd be like, Rolf is now 0. This would create a new dictionary. But this set item function is not creating a new dictionary, it is modifying self. That is why it mutates the data, it does not recreate it. So what happens when we do this? Well, something happens when we add myInt plus 1 together. this happens. myInt add 1. But the difference is the add function takes in the value of self and returns a new integer object, potentially something like this. I'm not exactly sure how the inards work, but all I know is that it returns a new integer object. It does not modify self, which could be, for example, self.value plus equal 1. This could modify self potentially. Okay. Note that myInt plus equal 1 is another function call, myInt iadd self1. If the int object was programmed to create a new int object when this function call happens, then the int object would not be mutable. It would be immutable. Because this iadd function is programmed to create a new int object every time, the int object is immutable. You cannot change it. So, immutability. All functions return new int objects. You cannot change existing int objects. This is why some of these things are immutable and some of them are mutable. Because you create new objects of their type when you call some functions, and in other cases, you never modify existing objects, you only create new objects. This is the concept of immutability, and it's sort of difficult to wrap your head around it, but in the next video we're going to look at some examples of where mutability matters. So I'll see you in the very next video.
Everybody can make a mistake, but the responsibility, what I used to say, when we travel, where we stay, we try to give always good message. This is a big responsibility.
Hi and welcome back. In the last video we looked at mutability, and now we're going to look at passing arguments in Python. Let's look at a couple examples of arguments in Python, and I'm going to show you this dictionary here. Dictionaries are a great example of mutable data structures. And then we'll create a function called seeFriend that is going to allow us to see a friend that we didn't see for a long time. So seeFriend, friend's name. And this function, all it will do, it'll say friend's name equals 0. If we pass in friend's last seen and Rolf, it'll set Rolf's value to 0 instead of 31. Now, here comes the interesting bit. We're going to print out the ID of friends here. Inside the function, this is the parameter friends. Then, we're also going to print the ID of friends last seen, which is our dictionary that is in the global scope. Finally, we are going to call seeFriend with friends last seen and Rolf, and we're going to print the ID of friends last seen. How many different numbers do you think we are going to see here? Hopefully the answer was one number only, but we'll see. Notice how the first thing we printed out was this friends last seen here, and it's a number. Then we called seeFriends, and we passed in friends last seen. The name changed over to friends, but actually the number is still the same. It's still the same dictionary, this one here. Finally, when we exited the function after changing the inners property of the friends dictionary, we printed out the ID, and it was still the same. Now let's do something else. I'm going to print the ID of friends last seen, Rolf, before we call the function. And then we're going to print the ID of friends last seen, Rolf, after we call the function. Notice how friends last seen, Rolf will have changed from 31 to 0. Now, how many different numbers do you think we're going to see printed out in total? 1, 2, or 3? Hopefully you said 3. Friends last seen Rolf here is the number 31. Friend last seen Rolf here is the number 0. Integers are immutable, so whenever we change one, that is a new integer being created. Let's run it. And as you can see, we have now 3 dictionaries here. We 3 different numbers here. The first one is this friends last seen. The second one is this ID of Rolf. That's this one here. Then we print the ID of the friends dictionary, same one as the first one. Then we print the ID of the new Rolf number, and notice how 2 and 4 are different. And finally, we print the ID of the dictionary again, which is the same. So this is mutability in action. What we've seen is that the friends last seen dictionary has not changed itself, but one of the properties inside it has. Even though at no point we have modified the friends last seen dictionary, we've only modified the value that we passed to the function in there. Let me delete the IDs so I can explain things a bit better without all that gibberish. So again, what's happening is that these variables, friends last seen and friends, are just post-it notes on the value being this dictionary specifically with this ID that we got. When we pass the value here, what's happening is that we are passing the value of the variable. We're not passing the variable itself. So the dictionary now gets assigned to friends. Friends is just another post-it note on the dictionary. Indeed, we can print whether friends equal friends last seen. The equal is going to compare the contents. So if there were 2 distinct dictionaries with the same contents, this would return true. But is compares for the IDs. So it's going to tell us whether they are exactly the same object. And when we run it, we get true. Because this friends variable here that has the value of friends last seen is actually the same as the friends last seen variable that was defined up here. The same dictionary exactly. Therefore, when we mutate one, that is changing the Rolf property of this dictionary up here. Therefore, friends last seen Rolf will have the value 0 after we run the function. There we have it. So mutability can be quite dangerous, because if you change the dictionary in this function and then you're thinking, hey, yeah, we've changed the dictionary, now we can use it. For example, say you wanted to use it here some more. You may not realize that it's actually changing everywhere else that you use that same dictionary. So it can be quite dangerous. Okay, that's the concept of mutability. However, if you go and have something like age is 20 and then a function that is increase age, and you do this, then you say ID of age, increase age, ID of age. What we're doing here is defining a variable. That is a post-it on the value 20. Then we are getting the ID of that 20. We're calling increase age, which has the value 20, so current age is another post-it on 20. And now we're saying this post-it now points to 20 plus 1. So that's 21, an entirely different number. Then when we return, we print out the ID of age. What do you think we're going to see? Are we going to see the same number twice, or are we going to see 2 different numbers? Oh, we see nothing because we didn't print them out. Let's see if you guessed that one. Let's print it. We get the same number twice. What does that tell us on the value of age? What is age here? Age here is 20. what is age here? Well, it must be 20 because it's got the same ID, and we know that numbers are all different objects. So what's happened is that this current age variable has the number 20 assigned to it. But then what we've done is we said, now the current age variable is posted on 21, not on 20. Age is still posted on 20. So the number 20 has not changed. It is only the variables that have moved from one to another. Again, an important concept for mutability. If you do this on an immutable object, it'll just change within the function. This variable will now point somewhere else, but the outer elements will not change. Let's give you a third example. A list of prime numbers. The ID of primes will be something. We'll have to remember to print it this time though. Then we'll say primes plus equal 7 and 11. And then we'll print the ID of primes. What do we think we're going to see now? We get the same ID back. That is some bizarre functionality, right? This one is primes equal primes plus 7, 11. Surely it should be a different thing. We've moved the variable from pointing to this list, now points to the longer list. But remember, when I said that this is equivalent to this, I was lying. It is not. What's happening here is that the primes is equal to primes dot IAD. That. And it is up to the implementation of this function whether it's going to modify primes or whether it's going to create a new list that determines whether this is going to be the same object or a different one. Okay? And in this case, in case of the list, and in case of a lot of objects, when you do IAD, when you do plus equal or minus equal or times equal or divide equal, Python, the Python official documentation says that when you do that, one of these IAD or ISUB or IMUL for multiply, they should modify the object if possible. So in the case of lists, IAD modifies the list. Okay. Of course, if you do primes equal 2, 3, 5 plus that, we're going to see two different numbers printed out here. Because these are two things. What if we do primes equal primes plus that? We also get two entirely different objects printed out. Again, what's happening here is primes equal primes add 7, 11. It is not IAD. IAD is meant to, where possible, modify self. Add does not have that requirement. And in the case of lists, it has been implemented so that it creates a new list. So this is why this creates a new list entirely. Okay. So it's all up to the implementation whether the objects are mutable or not. So enough of this. Just remember when you pass something to a function that you can potentially mutate that thing and then the value outside the function will have changed too. For example, with dictionaries, and you can do it with lists as well if you use plus equal, or indeed any other of the I something functions. Unless the thing you pass to the function is immutable, in which case when you try to change it, it won't have changed outside the function, only inside. Essentially what you've done is you've moved the variable from one place to another. Okay, that's it. I hope that this starts to make a little bit of sense. As you program more in Python, I think you'll be glad to have received this lecture from me in order to understand a bit more of what's going on behind the scenes with mutability and different variables. It really is a frequent question on a lot of online Python forums, questions, and Stack Overflow. So it's really good to know that this is how things are handled. So with that said, I'll see you on the next video.
What makes you different if you identify that and you realize that, all right, This is what's different about me. If you think about it, that's exactly what makes you unique. Be the best version of yourself. Because the more different you are, the more special you are.
Hi and welcome back. In this video we're looking at default values for parameters. If you already know a bit of Python, you may wonder why we didn't cover this earlier. And quite simply the reason is that we didn't need it. Now we do, and we're going to start looking at a couple of instances where having default values for parameters is going to be useful. So let's get right on it. Whenever we call a function that has parameters, we are expected to give it an equal number of parameters. We already know this, so I'll show you some example code. Here's some accounts, like a checking account. Let's say that has $958 in it, or pounds if you're in the UK. 695.50 in your savings. It's a pretty respectable amount of money. Then we're going to have a function add balance, which is going to take an amount, which is going to be a float, and a name, which is going to be a string, and it's going to return a float. Notice how I'm including in here the type hinting that we've looked at in the past. Also, just for completeness, I'm going to say function to update the balance of an account and return the new balance. Include that doc string in there just so you know what this function is all about. As you can see, this function add balance is going to update the balance of an account and return the new balance. The two arguments it takes are the amount to increase the balance by and the name of the account that we're going to change. Then it's going to go over to your accounts global dictionary and it's going to change it. So, accounts name plus equal amount. And then it's going to return account's name. It's going to return the new balance of the account. Account's name, for example, for checking is going to be 1958. Let's say we say 200 in here. It's going to go increase it by 200. I'm not even going to try to do maths here. Then it's going to return the new amount of account's name. So that should be a float. However, what we can do, of course, is add balance 500.00 to savings, and then print account savings, and it should tell us the new balance, which should be in the 4000s. Accounts savings. As you can see, 4195.5. Notice how the 0 at the end gets dropped, but in my code I like having two decimal places for currency, just to keep things clearer. What you didn't know that you could do is you can say that by default, all new balances are going to go to your checking account. So the name here is going to be checking by default. And the way we do that is we add equal checking. Okay, so the name is a string and its default value is checking. That means that if we do not pass a string to this argument, which we can do now, we cannot pass a string to it. We cannot pass anything to it. And we print out the checking at the end, we should see it has increased by $500, or 500 units. If you don't want to use type hinting, then all you have to do is get rid of that. Okay, and this stays the same, name equals checking. And that's that. Okay. Frequently, actually, if you don't have type hinting, you'll see this written like so, without the spaces. And when you do have type hinting, you'll see it written like so, all with spaces. It's up to you how many spaces you want to put in there, whether you want to put spaces or not spaces. Totally fine. Now, something important that you have to know about these named arguments, this is what they're called as soon as you have the default argument there, is that you cannot have this here. Sorry. You cannot have this here. This will be illegal. And when you run it, it'll tell you here. Syntax error. Non-default argument follows default argument. So you cannot do this. Any argument that has a default value has to follow arguments that do not have default value. So in this case, the amount does not have a default value. The name does. So the name has to go at the end. And if you have many arguments, some of which have default values, they must all go at the end. Okay? That's it. This is default values for arguments. You can have many arguments, many default values, one default value per argument, of course. And we're going to learn more about these default values and how to use them in subsequent videos, in just a couple of videos. In fact, in the next video and in coming videos too. So that's it for this one. I'll see you on the next one.
I said, empty your mind. Be formless, shapeless, like water. Now you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put it in a teapot, it becomes the teapot. Now water can flow, or it can crash. Be water, my friend.
Hi and welcome back. Mutable default arguments. It's a terrible idea. So here's a common pitfall in Python that you definitely want to avoid, and that's the mutable default arguments. You know what mutable means, and you know what default argument means, so let's join them both together, and let's take this function here. I'm going to say create account, and it's going to take a name of the account, which is going to be a string, an account holder, which is going to be a string, that's probably the name of the account opener, and also account holders, which is going to be a list, and it's going to equal an empty list at the start. So the logic behind this is that you're going to create a new account with this name. This is going to be the account holder, and it can have also other account holders as well, and they'll be coming through in this list here. So you can give it a list of account holders. So we'll say account holders dot append holder. By default, when you create a new account, you'll append the holder of the account that you just added over to the account holders list. And if there are any other account holders in that list, you will also use them. And then we're going to return a dictionary representing our account. So that's going to be the name of the account, the main account holder. That's going to be the holder parameter here. And then it's going to be account holders. It's going to be the account holders list. Again, how we call this is we have, for example, an account 1. Let's create account, a checking account, and the holder is Rolf. Notice how we don't have to pass an argument to the account holders parameter because it has a default value, which is this list. So what's going to happen is the name is going to be checking, the holder is going to be Rolf, and to the account holders, which is an empty list, we're going to append Rolf because that's the only holder in the account, and then we're going to return a dictionary, which is the main account holder, which is Rolf, and a list of account holders, which at the moment only includes Rolf. If we wanted to have multiple account holders, we could do this, for example, and then the account holders would be Jen and Rolf, because we append the opener, the main account holder, over to the list of account holders. But let's say we don't want to pass in an argument to this list. We just want to create an account, and this will be handled for us. It will put Rolf into this list. Then let's create another account. Let's say a savings account, but this time Jen is the owner of the account, and let's imagine they've got some sort of shared finances there, and she's the owner of the account, and she's the only holder in that account. Let's say Rolf sends her the money every month. Now, A2 and A1 are both dictionaries. That's what this function returns. What are we going to see when we print A2? This is a trick question, of course. I know that you already know about functions and dictionaries, so why would I ask you this? This is a trick question. What is it going to return? And important, try this out first if you don't want to be wrong. Hopefully you tried that out. As you can see here, what we see is the name is savings, the main account holder is Jen, but the account holders are both Rolf and Jen. So how did that happen? This function here never saw Rolf anywhere. Rolf didn't get passed to the function. It's not in any of the arguments. I've not hard-coded Rolf in here. So how did this happen? Well, what happened here is that the default parameter for the createAccount function gets evaluated when the function is defined, not when the function is called. So this list here, and what this parameter points to by default, is this object. So this gets created when the function gets created, not when the function is called. I'll make this clearer for you. I'm going to here print the ID of account holders and run this again. And notice how in both times we run the function, the ID is the same. When we didn't pass a parameter, an argument here, we used this list. We didn't use a new list, we used this list. And that was defined when the function was defined. So it's always the same list for every time the function gets called. So when we modify the list, when we mutate it, that's still the same list the next time the function calls. So now it contains Rolf, first of all, then it's going to modify to contain Jen again. And if we do this again, it will be Rolf, Jen, and someone else. So there are two ways to solve this problem. This is a common problem, by the way, and not one that a lot of people realize, and a lot of people start doing this, and then they're like, what the hell is going on in my code? I do not understand it. So, two ways to solve this problem. First one, of course, is to not have a default argument. Simple enough. Don't have a default argument. Instead, pass in an empty list here. These empty lists get evaluated when the function gets called, so they are going to be empty every time. There's a new empty list, new empty list. An option, of course. The second option is to not make this a list, but make it equal to none. Okay, then you don't have to pass anything here because it has a default argument, but of course it's none, so you can't append to it. So then what you'll do is you'll say if account holders, if not account holders, so if account holders is none, then say account holders is now a list. And then you can append to it. So what does that do? If you don't pass a list in here, it'll create a new one. And if you do pass a list in here, say, for example, Jen, it will use this list and it will append to it, and the account holders will end up being the holder and whomever else you defined in here. So those are your two options to avoid mutable argument problems. Mutable arguments are, of course, any data type that is mutable. You can have dictionaries, lists, you can have objects of your own types, and so forth. If you want to avoid these problems, use immutable data types as your default values. Integers, strings, floats, tuples, and so on. That way you cannot change one, and it won't change across executions of the function. So that's it for this video. I just wanted to make you aware of this very, very common pitfall so that you don't fall for this trap. So that's it, and I'll see you on the next one.
Be with your failures. They're just as educational and just as opening to the process as the successes. And eventually, if you're, I would hope, the notion of success and failure will begin to dilute as well. So yeah, just practice.
Hi and welcome back. In this video, we're looking at argument unpacking. We've looked at tuple destructuring, and this is sort of fairly related. It's not the same thing by any means, but it's sort of a shorthand to do things. Given the code that we've got here on the left, which should look familiar, is the one we wrote a couple of videos ago, we've got our accounts, and we've got a function to add balance to an account. Let's call the add balance function many times. Imagine we've got a list of transactions like this list I've just pasted here. So it's a list of tuples. This one says the amount of change that happened, and this one to which account it happened. So let's go over these transactions. I'm just going to press enter a few times here to give you a bit more space. And let's say we wanted to add all of these transactions to our accounts. What could we do? For t in transactions, add balance, t0, oh, sorry, forgot the bracket, t0, t1, and that's it. So as you can see, what this will do is, of course, for every transaction which is a tuple, it'll call t0 and t1, the amount and the name, and pass it to add balance, which it takes in the amount and the name of the account and is going to update it. Now, we're doing something very, very specific here, which is a really popular thing to do, in fact. And that is that we're getting an iterable, like this tuple here, and each element of the tuple, in this case 2 elements, we're passing them as arguments to a function. Notice how we're passing the first argument, the argument with index 0, to our function at t0 as the first argument. So the first argument of the function is also the first element of the tuple. The second argument of the function is also the second element of the tuple, and so forth. So this is a very popular thing to do. Each element of the tuple going to an argument of a function. So Python gives us a shorthand. Instead of this, we can do *t. And what that does is that unpacks the iterable into arguments. So *t will pass each element of t as a separate argument to the function. So t0, the amount, will go to the amount. t1, checking, will go to the name. If we had more elements here, they would go to the subsequent parameters as well. Of course, we only have two elements, 2 parameters. So this is called argument unpacking, and this asterisk here is the unpacking operator that we can use to unpack any iterable into arguments. Okay? Pretty straightforward. Now I also wanted to tell you about named arguments. Did you know that in any function call in Python, you can specify the name of the parameter that you're fulfilling with a given value? So you can say something like amount equals t0, name equals t1. This is totally valid Python. So you define the name of the argument, the name of the parameter and the argument value, and you put them an equal sign in the middle. That just makes the function call a bit more readable, so that when you're looking at the function, you know, okay, t0 is the amount, t1 is the name. It becomes a bit less useful if you have a statement above it that says something like amount equal t0, or let's use proper amount name equal t. This becomes a bit less useful, and then you have amount equal amount, name equal name. So this is not so useful, so you wouldn't do this in that case. But when you have a variable that maybe doesn't describe what things are so well, like this t thing here, this can be pretty useful. Because now you know that, okay, t0, whatever that is going to the amount property. t1, whatever that is going to the name property. So t1 must be a string, t0 must be a float, you assume. A benefit of these named arguments is that you can put them in any order you want. So you can put this one here, and this one in front, this one behind, it doesn't matter. It's up to you. So that's named arguments in a nutshell. That's really all they are. You can put the name of the parameter you're fulfilling in front of the value, and then you can jumble them if you want. Okay. So in section 9, a while ago, I'm just going to add some more enters here. In section 9, we looked at this piece of code here that I'm about to paste in. We looked at this piece of code. I don't know if you remember it. We defined a class user with an init method. Username and password were 2 arguments to the init. And then we set the properties username and password of the object. And then it had a class method from dict that took in a dictionary and created a new object of type user from 2 keys, username and password, in that dictionary. An interesting thing here that I notice pretty quickly when looking at this data is that we've got username and password keys in our dictionary, and we have username and password argument names. So they match. The data that we have, which has a username and password key, matches the argument names, username and password. So this is going to be interesting in a moment. Then we had a list of users. We can imagine that they're coming from a database or something. We've got username is Rolf, password is 123, username Teclado is awesome, password is UR2, and these are 2 dictionaries here. And then at the end, we mapped over the user.fromDict method for the users list. So that calls the fromDict method for each user, for each dictionary here, passing the dictionary to the method, and then we were able to create a new user from each dictionary. And we also, of course, had the option of saying user objects is user.fromDict, U for U in users. We had the option of doing this list comprehension as well, although at the time I suggested that the list comprehension maybe was a bit worse, because we've got to create this empty variable. The function is already defined, so it's pretty handy to use that here. We don't have to create a lambda function. It's all good. However, now that we have argument unpacking, and I'm about to introduce a new type of unpacking, now that we have argument unpacking, in fact, we don't need this method at all anymore. And in fact, we don't need this either, because what we're going to do now is we're going to do this. We're going to do data username, data password. Okay, so I'm going to build this up. This is nothing new for you guys. we are iterating over users. We're calling each dictionary data. So this dictionary is data, and then this dictionary becomes data. And every time we do that, we're creating a new user object, passing to it data username and data password. So Rolf goes to username, 123 goes to password. We have a new user where the properties are username and password. So we know that. We can make this a bit worse and make it username equal data username, password equal data password. Again, same thing, only now we're using named arguments. We're giving a name to the argument that we're passing in, and that has to match the parameter here. So we're saying username is the data's username property, or key. Password is the data's password key. Whenever you see this, username is something username, password is something password, a dictionary, you know that, you've got duplication here. There's too many usernames in here. There must be a better way. And there is. Instead of doing this, you can do that. I'll do this again. Instead of doing this, you can do this. Notice the double asterisk now. And what this does is this is a dictionary unpacking. It unpacks a dictionary as named arguments to a function. So it does exactly this. It says, get the key of each dictionary, in this case it's username and password, and treat them as named arguments to the function. So say, username is data username, and then, this is another key in dictionary, password. Let's treat that as another named argument equals data password. So this double asterisk data does exactly the same thing as this. Why is that important? It's important because the dictionary may not be in order. And remember, these two can be jumbled up, and that's fine. So you can put the password in front if you want, and it'll still go to the right place because Python can now match them to the name. So that's important because when you do the double asterisk data, the dictionary may not be in order, and that's important here as well. However, let me say that as of Python 3.7, dictionaries do keep their order, and when you pass this mapping into a function, it'll keep the order of the dictionary as well. And it's not really a problem anymore, but nonetheless, you can still do this, and this is a good thing to do. If you were getting these things from a database, for example, you can see how being able to pass the entire piece of data to a function may be useful. Okay, that's how you do named argument unpacking or dictionary unpacking. Of course, if your users were in a slightly different format, if your users were in the format, I'm just going to copy from my notes just to save you the pain. If your users were in this format, a tuple format, where username is the first element and password is the second element, you know what you can do instead, right? You can just do this. So for each tuple here, you are going to pass them as normal arguments. The normal arguments are called positional arguments. And so same thing here. You can pass them as positional arguments to the user function. So in this case, Rolf would be the first parameter. 123 would be the second parameter. And now you don't know whether it's a username and password. You just know this number 1 and number 2. And this is something you can do as well. Of course, only if the properties are in this type of iterable and not in this type of mapping. Okay, that's it for this video. I wanted to show you about this unpacking and also about named arguments because it's a useful thing to know. Sometimes it can make your functions a bit easier to understand. So that's it for this video. I'll see you on the next one.
A real man is not violent, and a real woman is not tolerant of it. Because what happens is society tells boys that it's okay to be violent, and then women just become tolerant.
Hi and welcome back. In this video, I wanted to tell you a bit about queues. And I just wanted to do that before the next video where we're going to be using one, just so you have a bit of an idea of what they're like and how you use them. So here's an example of what could be a queue, with a nice little animation there. And here's a more realistic example of a queue. Let's say you've got a queue of people to get into some sort of building, And of course, people are going to join the queue at the end, and they're going to leave the queue from the start. So this is a queue. You know how queues work already, particularly if you are in the United Kingdom, where we like to queue for everything. And it's really the same thing in programming. Let's say you've got this list here, and you can add an element at the end of the list. Like so, we've added gen to the end of the list. And normally we do this in a list with the append method. Now what you didn't know is that there is a data structure, like a list, in which you can also remove an element. And that would be, for this structure, the pop left. So the structure here that I'm talking about is called a double-ended queue. I'm going to talk about that in a minute. But for that double-ended queue, the pop left will remove the leftmost element, append will do the same thing as for a list. And if you think right to left instead, if you sort of turn it around, then the ends are opposed, and you've got this list to begin with. You can append something on the left, and of course that would be called append left. And you can remove something from the end, and that's just called pop. So what you're seeing here is that you can add elements from either end, and you can remove elements from either end. So a queue where you can add or remove things from either side is called a dequeue, or actually it's commonly said as deck, which I think is very weird, or a double-ended queue. So there's a deck or a double-ended queue. If you can only add elements from one side and remove them from the other side, like a normal queue, that's called a queue. So you'll have both of these in programming. Python has something called a deck, a double-ended queue, and it also has something called a queue, and you can use those. Now, something else that's very similar to queues is this thing that we've got here, and this thing is called a stack, because on a stack, you can remove things from the top, and you can add them back on the top. Notice how in a queue, you can add things from one end and remove them from the other, mimicking a real queue, like when you queue to go to the pharmacy or something. And in a stack, you add and you remove from the same end, so that it's like a stack of cards or a stack of coins. And these have different uses. Throughout the next few videos, we're going to look at some uses of the queue. We're not going to look at uses of a stack. I found that they're not all that useful in day-to-day programming. They can be useful in very limited scenarios. So we're not going to go into using stacks, but we're going to go into using queues in the very next video. So I'll see you there.
You can't let your failures define you. You have to let your failures teach you. You have to let them show you what to do differently the next time. So if you get into trouble, that doesn't mean you're a troublemaker. It means you need to try harder to act right.
Hi and welcome back. In this video, I wanted to tell you a little bit about some interesting Python collections that come built in with the language that you can use for a few different things. So the main purpose of this video is to make you aware that these things exist. Because once you know they exist, later on, you may find a situation where using one of them could be useful. Again, going with the analogy of the tools and the construction project, I'm just giving you a few more unorthodox tools that nonetheless could be useful. Normally what happens in one of the situations where we could do with one of these tools but we don't know about them is that we have to work really hard to build one that works well. Instead of doing that, you can just use one of these. So, let's get started with the first one. The first one is going to be a counter. A counter, as you can imagine, allows us to count things. So you can give it an iterable or a mapping, like a dictionary, and it will turn it into a counter of elements so you can count how many there are pretty easily. Again, how you do is from collections import counter, and everything we're going to be looking at in this video comes from the collections module. These are some pretty useful collections. Feel free to look up the Python documentation if you want to learn more about these or others that are there. And what we're going to do is say something like device temperatures is 13.5, 14.0, 14.0, 14.5, 14.5, 14.5, 15.0, and 16.0. Let's imagine we've got some sort of thermometer that's been doing some readings, and we want to find out what the most common temperature of our system is. We could do some really contrived thing where we loop over it, we keep track of the ones that we've already seen, we increase one every time we look at it. Generally, I mean, that's just giving me a headache just thinking about it. So instead, we can do temperature. Counter is going to be a counter of device temperatures, and then we can print temperature counter 14.0. So access it as if it were a dictionary. Just access the key that you want to get the count from, and you can see that it gives you 2. And if you go for 14.5, it gives you 3. Pretty simple counter. You can give it a dictionary as well, and it will also turn it into a counter of things. So, for example, you could have a counter of greetings, how many times something has been said. Let's say hello has been said 5 times, hi has been said 3 times. Then you can access a particular one, and it will just tell you again how many you've done. So here again you get the 3. This one's not that useful. The official Python documentation uses this example. I'm still not 100% sure on why you would do this. After all, you do have the counts here. You don't need to wrap them in a counter for anything. But I can see the usefulness for a list. So who knows? Maybe I'll find a situation where doing this is useful later on. But I've not yet been able to use a mapping, a counter mapping for anything professionally. But I've used this, and it can be quite useful. Okay, that's the counter. Very simple. Again, if you want to learn more about counters, feel free to check out the official Python documentation. It'll be in the further reading lecture of this section, so feel free to check that out. Now, the code for this video will all be available all together, but I'm going to just delete it and go over to the next collection here just to keep things a bit simpler. But the code will have each counter, sorry, not each counter, will have each collection all in the same page. So let's move on to default dict. As we know, when we have a dict such as this one, hello, was said 5 times, for example, and we print my dict hi, we know what's going to happen when we do this. It's going to give us an error. And indeed, as you can see here, we get a key error on hi because it doesn't exist. The default dict never raises a key error. Cool. So that's not it though. Instead, it returns the value returned by the function specified when the object was instantiated. Whoa, that was a mouthful. Let's do some code. From collections import default dict, and what we're going to do is we're going to have a list of co-workers and where they studied. So here we've got a list of tuples where the first element of the tuple is the name of the co-worker and the second one is where they studied. So you can see Rolf went to MIT, Jen went to Oxford, Rolf then went to Cambridge to do a master's degree, and then Charlie went to Manchester at the end. Now, let's say we wanted to create a dictionary that maps names to where they've been. Something like this. Rolf went to, forgot the colon there. Went to MIT and Cambridge. And then Jen went to Oxford. And then Charlie went to Manchester. There we go. Imagine we wanted to make this dictionary, but we only have this data. So an option would be to go over each element and put them in a dictionary. Something more or less that looks like this. We'd create our dictionary, alma maters, which just means places where they've studied. Then we would iterate over our co-workers list in co-workers there. Now remember, co-worker is now a tuple. 0 is Rolf and 1 is MIT. So we would say alma maters co-worker 0 is an empty list, first of all, and alma maters co-worker 0 dot append co-worker 1. So co-worker 1 is MIT, and what we're doing is we're accessing the Rolf value of our dictionary, which has just been initialized, that's the word, has been initialized to be an empty list, and we're going to append to that empty list the place where he's been. Now this works fine as long as they only appear once. The first time they appear, in this case Rolf, we initialize it to an empty list, and then we put MIT in it. Then we do the same for Jen. We initialize her to an empty list, and we put Oxford in. But then we come back to Rolf. And what we do is we once again set it to an empty list. So we delete MIT, and then we append Cambridge. So we couldn't do this. What we would have to do is say something like if coworker 0 in alma maters, not in alma maters, set the value to the empty list. And if they are in alma maters already, it means we've done this before. We can just append to the list that we've already initialized before. Not the simplest way of working with code. Of course, we can make it simpler by destructuring the tuple here and just say coworker, 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 place. Saves us from accessing the indices separately. We could do this. Of course, this editor removes closing brackets for you, which is not a great feature. So we could do this a bit better, still not brilliant. And as you can see, what we're doing here is also, once again, something that's very common to do, which is to add things to a dictionary if they don't exist yet, and otherwise treat them as though they exist. So what we're doing is, when we don't have an element in a dictionary, we're going to set some default value for it, and after that, we're just going to treat it as though it's already there, for example, appending to the list. Naturally, the default dict is here to save us. We can do default dict list. List, remember, is a type. When you have something like this, that is of type list. And therefore, because it's a type, it's a class. Classes and types, same thing. All things in Python are classes and objects. And so this is a class name. Therefore, it's a function as well. And remember, we can call our user constructor when we initialize a new user. It's a function call, essentially. List is also a function call. And I said earlier that the default dict takes in a function. This is the function that it takes in. And what happens is, when we try to access something that doesn't exist, like Rolf, it gives us the result of this function. So it gives us a new empty list. That's what this function does. It gives you a new list. So it gives you a new list, and then you can append to it. It does exactly the same as before, only now we have a bit less boilerplate. So we can do something like print coworker, alma maters. Alma maters Rolf, that should print out 2 things. Print alma maters Anne, and that should print out 0 things. Let's run it. And as you can see, we get MIT and Cambridge for Rolf. And for Anne, which didn't exist, we didn't have her in her list here. We just print an empty list because that's the default value for anything. Okay. Now, if you wanted to raise an error or potentially print out none when you try to access something that doesn't exist, you can always do alma maters default factory equals none. And notice how then you get a key error, because now you've removed the default factory, which is this list, and Anne doesn't exist. But Rolf does, so you still get the default factory working in this bit of code here, just you don't get it working after this line. So this is a nice tidbit here, in case you want to remove the default factory and not just be returning empty lists for everybody. Okay. And similarly, you can, of course, also do alma maters dot default factory is now an int, for example. Then whenever you try to append, it will give you an empty integer, which is 0, the value 0, and it will fail. But you can do things like, do something else with an int with the number 0. You can change the default factory, is all I'm trying to say, from list to dictionary or tuple or whatever you want. Okay, let me give you another example. So I'm going to delete all this stuff here. And let's say I've got my company, which is called Teclado, and if you don't know it, shame on you. Then we've got our co-workers, which let's say are Jen, Lee, Charlie, and Reese. Some of these are actual co-workers of Teclado. Other co-workers, those are co-workers that don't work at Teclado. We are going to say they are, for example, these tuples of Rolf and Apple Inc. Lucky guy. And Anna is going to be working at Google. as you can see, these two have different structures. For my coworkers, I already know where they work. I only have a simple list. Potentially a tuple could be better. It doesn't matter. For my other coworkers, I've got a list of tuples where I define the name and also the place they work. So, what to do is define a place like coworker companies, and this is going to contain something that is going to be like this. Jen works at Teclado, Rolf works at Apple Inc., and so forth. So a mapping of names to the place they work. How to do this? Default dict, lambda, my company. My company is this variable Teclado. This is a lambda function that doesn't take any arguments. There's no x before the colon, or no parameter name before the colon. Doesn't take any arguments. Always returns my company. Why can we not just set my company there? Because the default dict takes in a function. So we have to set a function that will be called when we access the key that doesn't exist. Then we're going to do for person, company in other coworkers. We're going to say coworker companies, person equal company, and that's it. Oh, no, not that one. There. Now, we can do coworker companies, coworkers 0. Remember, this is going to be Jen, our coworker from Teclado. And we can also print coworker companies of other coworkers 0. 0. So this is going to be Rolf. In order to simplify things, I'm just going to type Rolf in here. Now we can run this. And as you can see, we get Teclado for Jen, and we get Apple Inc. for Rolf. Rolf and Anna are actually in this dictionary when we finish the for loop. Jen, Lee, Charlie, and Reese are not in the dictionary, but whenever we access them, we get the value returned by this function, which is Teclado. So this is a slightly more contrived example, maybe not a terribly useful one, but nonetheless, this is how you use a default dictionary. I wanted to give you this lambda example here in case you want a default value that isn't initialized by a function. So just remember, you can use a lambda function here. That's fine. You can use lambda functions anywhere where you can use normal functions. So what we've done here is created a mapping of the other coworkers, and then we can also access it for our own coworkers because we know where they work already. Okay, that's it for this video, for this collection, the default dict. We're going to move on to ordered dict. So let's do it. The ordered dict actually is a bit of a bizarre one because it has the capital letters. So just remember that. Remember the capital letters. Ordered dicts, not so useful. We're gonna look at them more quickly, just because they're going away soon, I think. And so as you can see, we are just accessing normal keys as if this were a normal dictionary. We're setting the values in those keys to 6, 12, 3. Then we can print them out. And what you'll see here is an ordered dict where the keys here are Rolf, then Jose, then Jen, and the values are 6, 12, and 3. Important is that they are in the order in which they were inserted. It does not mean they are ordered alphabetically or anything like that. It just means they're ordered in the way they were inserted. So Rolf was the first one we added. Rolf is always going to be the first one there. Okay. You can also do o.moveToEnd Rolf. And that is going to move Rolf to the very end of this dictionary. As you can see, Jose is now first, Jen is second, Rolf is now at the end. You can also do o.moveToStart. My bad. I wish that was the case. Move to end, Jose, but now last is false. And instead of it being the last, it's going to move it over to the other end, which is the beginning. But I'm going to move Jen, of course, because Jose is already the first one. Now you can see that Jen is the first one, Jose is in the middle, and Rolf's at the end. Okay. Something else you can do is pop item. And this is going to give you a new dictionary where the last item has been popped off, has been removed. So pop, pretty popular programming term. It just removes an item, and it normally removes items from the end. And so that's what we see here. we've popped off the last item in the dictionary. So I don't think order dict is going to sort of really go away, going to be deleted from Python, but it's not so useful now because as of Python 3.7, dictionaries themselves are going to be retaining the order in which they are inserted. So it's going to be slightly less useful, the order dict. It's still useful to keep these functions, move to end, and move to start, and pop item, and stuff like that, which isn't in normal dictionaries, but the fact that they're ordered is going to be less important now, because in Python 3.7, as I said, normal dictionaries will start keeping the order. Okay, let's move over to the next collection, and that's the named tuple. I gotta love this. Named tuple. I love the named tuple. And the named tuple is another object that we can use just like a tuple, but each of the elements has a name. And in addition, the tuple itself also has a name. So it improves on tuples by making things a bit more explicit. Let's have an example here. A checking account that has $850.90 in it. We can print account 0, and we can print account 1, but it's not so clear what these are unless you're looking at a tuple. If the account was being read from a database and the code was a bit all over the place, you wouldn't necessarily know what account 0 is, which is, of course, the name. And you wouldn't necessarily know what account 1 is, which is, of course, the balance. Maybe you'd think this is the overdraft amount. Maybe you'd think this is some sort of tag for the account. I don't know. You could think anything because it's not terribly clear what they are. If you wanted much more clarity, you could create a class for your account and have a property called name, which was checking, and a property called balance, which is the balance. Or you can use a name tuple. So we're going to define a new name tuple. Notice how I'm using capital A here. And this is going to be a new named tuple. The first parameter is the name of the tuple. And that has to be the same as the definition here, account. That's because of the way Python works. It can't quite see the name of the variable first. So this name here has to be what you want your type to be. Then in a list, we're going to define name and balance. So these are the two fields on the tuple. The first one is checking, and the second one is the balance there. Then we can do something like account is account checking and 1850.90. So as you can see, now we've used this named tuple instance to create a new instance of this type account. It's essentially the same as a tuple, except now we can print account.name, for example. We can use the field names. And indeed, we can also print the account itself if we want, and that's it has a nice representation, a nice dunder repr method here. I like to think of it very much like defining a class, where account is the class name or the type, but it's not quite the same. Name tuple is still a tuple after all. You don't have any custom methods that you can define in a class, and so it's like a nicer tuple that allows you to be a bit more explicit with what things mean. That's the word. You can still do things like name, balance is account. Tuple destructuring. You can still do tuple destructuring. When you define the account, you can have, of course, named arguments in here, like you can in any function. You can use positional arguments like the checking here, or you can use named arguments like here. This makes things much nicer for you to be explicit in what it means when you create a new account. Given a tuple like this account here, you can have an account named tuple, which is account._make account. So this is the type. ._make takes in a tuple, and it will associate each element here with the respective field. This is particularly useful for when you're using the map function. Otherwise, you can, of course, do this, and that is the same thing. You can also turn an account name tuple. You can do as dict. Let's print that one out for you to see what that is. You can print it out as an ordered dictionary where it keeps the field orders. Name goes first, balance goes second. You can get it as a dictionary. You can then, of course, access it as a dictionary. You can use this square bracket notation there, and that gives you the number, 1850.9. So it's a pretty useful thing when you're dealing with data and it doesn't warrant creating classes for the data elements you're working with. Like, for example, when you're reading from a database, you're reading from a CSV file, name tuple is a great choice, and it's really flexible, and it just makes things more explicit and more clear with what's going on. So definitely something to keep in your arsenal. I think it's pretty nice thing to use, so definitely remember it. Also, the guy that made this, Raymond Hedinger, is a pretty cool guy. He makes a lot of nice Python talks, so what he's made here is useful. Let's move over to our last collection, and I know I'm boring you already, which is the DQ. The DQ stands for double-ended queue. So please watch the presentation about queues. If you haven't done so already, it's just the video prior to this one. And in a double-ended queue, it's just like a queue, but we can push elements from either the start or their end, and we can also remove elements from either the start or the end. It's very efficient, it performs very well, and it's just essentially like a list, but you can append or prepend, start and end, and you can pop from the start and from the end. The most important thing about the DQ, and the main reason why we use it sometimes instead of a list, is because of its efficiency, first of all. Secondly, because it's thread safe. So you can use DQs when you're dealing with threads. And we're going to look at threads very soon. I know that we've not looked at them yet. But essentially a DQ is really useful when you're dealing with threads because all its operations are thread safe. So when we look at asynchronous development, we're going to be looking at the DQ a bit more. For now, just remember it's like a list on which you do operations that are very much like a list. So for example, friends can be a DQ where they get, let's say, Rolf, Charlie, Jen, and Anna. And then you can do things like friends append, Jose. What is happening in the DQ constructor is you're passing it an iterable, and one by one it is appending them to itself. So this tuple here then gets turned into the DQ objects, or the elements of the DQ. You can then append to it. You can do like friends.append left, Anthony, for example, and that Jose will appear at the end of the list, of the DQ rather. Anthony would appear at the start of the DQ, and you can also do friends.pop, that removes an element from the end, or you can do friends.pop left. Append left is with a capital L, my bad. You can do friends.pop left, that removes an element from the end, this one removes it from the start. So these are a couple of things you can do, just to show you. You can print friends, and you can print friends here. And then see that you get the DQ here with all the elements, and then you've popped one off each end there. For more info on DQs and a comprehensive example on everything you can do, check out the official Python documentation. It is linked on this lecture as a resource. And so have a look if you are keen. If not, when we move over to asynchronous development, we're going to be using it a bit more, and you'll sort of understand why we use it instead of a list. So that's it for this video. I hope I've not bored you too much with these collections. I just think they are really useful tools to keep in the back of your mind, and at some point you may need them. So it's always a good idea to remember that these exist. When you do need them, just know, I think something like this existed. Let me have a look at the official Python documentation and see if I can find it. And then you'll be able to find it. If you don't know it exists, you're going to have trouble. You're going to be trying to recreate your own double-ended queue instead of using the one that's already provided, and it works, and it's tested, and it's validated that it all works. So that's it for this video. Thanks for watching, and I'll see you on the next one.
I'll tell you one thing that I've learned, that nobody's going to remember what gown you wore or what makeup you had on or what your jewelry was like or whether your nails were painted, but they will remember how you treated them. And that's the biggest lesson in life. It's how you treat people. That's the legacy you leave behind.
Hi there, and welcome back. In this video, we're talking about time zones. If you've never heard of a time zone before, that's a bit strange, but a time zone is essentially a slice of the world where it is a time at any point in time, and the time differs between other time zones. That's essentially what they are. So there's a lot of time zones. There's a lot of countries in the world, and of course the time here in the UK is not the same time as in, for example, Madrid. It's not the same time as in Shanghai. So the times are different, of course, because we generally want there to be sunlight during the day, and we generally want it to be dark during the night. So not every country is light during the same time. Some countries are dark when here it is light, and so forth. So the time varies depending on where you are in the world at any given point. So some countries have actually many time zones. For example, the United States has a few time zones. As you go from left to right, it's a very large country. So sometimes the time changes when you are within the same country. That's fine. However, some very large countries only have one time zone. For example, India is an example. Which can be a bit strange because, of course, when you are at the leftmost part of the country, it is a given time, and if you were to teleport to the rightmost side of the country, it may be dark, but it's still the same time. Normally, the difference between two adjacent time zones is of 1 hour. That's just the most common thing. So, for example, I am in one time zone here in the UK. The adjacent time zone is sort of European West time zone, like Madrid and Germany. And the difference between here and there is 1 hour. However, something that a lot of people don't know is that sometimes the difference between two adjacent time zones can be less than that. It can be 15 minutes, it can be 30 minutes, it can be 45 minutes. So, time zones are not all that stable. Also, some countries pick out a time and a time zone because it suits them sometimes politically, sometimes to be in the same time as neighbor countries that they have good relations with, so forth. So the time zone is not really, or it is sort of depending on your position in the world, but it's not really dependent on your position in the world. So it is dependent on the country that you're in, essentially. So what time is it right now? My computer says it is 2018, February 11th at 10:34 a.m. But of course, to you, if you were watching this live right now, to you that might be a lie. For example, if you were in America at this time, the time could be 2 a.m. So this is a lie unless I tell you where I am. If I tell you where I am, then I'm not saying that the current time is 10:34 for you. I'm just saying the current time is 10:34 for me in my current location. So the current time right now is 10:34 in UK London, and the time zone for this is called GMT. But it's actually 11:34 in Spain / Madrid, where the current time is Central Eastern. Or Central European. That's Central European time. I'm pretty sure that's Central European. Never mind. Central European time. However, it's 2:34 a.m. in San Francisco, which has PST, and it's 6:30 in China, in Shanghai, where they have Chinese Standard Time. So as you can see, that is the time right now. Any of those is correct, because I am telling you the time and also the time zone. That way, for you, when you know the time zone, you can convert my current time into your current time without a problem. So the question becomes, can you never speak of dates without mentioning a time zone? No, you cannot. However, there is a central reference point that everyone can use. Normally, when we don't say the time zone, we must imply it. We must say, we don't mention the time zone because this is the sort of the default time zone. And so that is UTC, which stands for Coordinated Universal Time. And yeah, I don't understand the acronym. But actually, that's also sort of a lie. I understand the acronym. You can Google it if you're interested in what the acronym means. It doesn't mean anything. But nonetheless, there is a central reference point. So normally when we don't specify a time, that's because we mean UTC, which is the central time. And the central time here in UTC is based not on political reasons, so it doesn't depend on the country. It was decided, and it sort of depends on a few factors. So the central reference point is important because when we talk about time zones, like for example CET, we say that it is relative to UTC by 1 hour. GMT is relative to UTC by 0 hours, and so forth. So every time zone is related to UTC in how far away they are from it. UTC passes through Greenwich in the UK. So for date and times in Python, there are two types of date and time entities. There's the date and time object in Python that does not know about time zones, and that is called a naive date and time object. You can create one like this. You can say from datetime, import datetime, and do something like print datetime.now. That is going to give you the current time in your computer, but it's not going to tell you what time zone that's in. So, not that useful, I would say. Because, for example, if you were to save that into a file or a database, when you come back to it, you won't really know if that was the current time in your computer or the current time in somebody else's computer, and whether how that relates to the current time in your computer. So you don't know exactly what time it was. One date and time object that does know about time zones is called an aware object, because it is sort of more aware of the world around it. And in order to create one of them, you can do from datetime import datetime and time zone, and you can print the datetime now, but giving it the timezone.utc, and that's going to give you the current time in the UTC time zone, which, as I said, is the central time zone. As an aside, UTC is not actually a time zone. Right? So it's just the central point, and in the Python datetime library, what we're importing here, it is treated as a time zone, but it's not actually a time zone. There is no country that uses UTC as their time. But it is the central reference point, and it's really an important thing. So in the next video, we're going to talk about dates and times in Python and how I advise that you work with them. Now, dates and times are a bit of a thorny issue and a bit of a difficult one at that. And there's a lot of different libraries that you can use to manage dates and times in Python. The built-in datetime library is pretty good, but it doesn't support some things and it supports other things. So there's always a bit of a trade-off to do between datetime libraries. If you find that what you want to do with dates and times is difficult with the included datetime library, feel free to look into other libraries which also can help you. An example of such a library is one called Arrow. That can be quite an interesting library to use as well. Nonetheless, in this course we're going to talk about what comes with Python, just because it is pretty powerful and it does a lot of the things we need, and which includes reading dates and times, understanding when a user types a date and a time, what it means, exporting dates and times and printing them out to users nicely, calculating dates and times, and for example, what time will it be tomorrow at this time, or what date will it be tomorrow at this time, and so forth. There's quite a lot of stuff we can do with the datetime library, so let's look into it in the very next video. I'll see you there.
Parents always told me, if you have an opinion, don't be afraid to share it. And my personality and the way I speak and my confidence is what won me that crown, made me feel like confidence is your best accessory. There is nothing else you need. The only thing you need to wear well is your confidence.
Hi and welcome back. In this video we'll talk about dates and times. Working with dates and times is an extremely useful skill, but it can be quite confusing. In this video we'll look at simplifying working with dates and times slightly using Python built-in modules. Now, I cannot teach you everything there is to know about dates and times. There's just too much, and it's always a contentious and difficult topic, but I can help you and start you in the journey and tell you a bit about how I work with dates and times and how you can work with your users and dates and times. The main date and time module in Python is called datetime. And confusingly enough, one of the most important classes in that module is also called datetime. So we're going to be doing from datetime, import datetime. So here we're importing this datetime class, which is going to allow us to do some stuff. For example, datetime.now. Datetime.now is going to give us the current time of our operating system. And as you can see, the current time for me is 15:45. Been recording for a while, should probably stop soon. Now, this is giving you what's called a naive datetime object. A naive object doesn't know about time zones, so it has no information about the time zone. Therefore, if I give this time to a computer in the United States, it's not going to know that they should show a different time. They're going to think, okay, the time that this is showing is 3:45. That's cool. What they don't know is that I am in the UK, and this is the time in the UK. So without a time zone information like this thing here, datetime objects are, I'd say, not very useful. And that's because you cannot give them to anybody. You can't show it to your user because you don't know if that time is correct when you're showing it to them. You don't know where the user is and where you were when you recorded this time, so you cannot possibly show them in a way that's relevant to them. For example, if I went to the United States with this time, it would be in the future. So, not great. So what to do is we can say print, not that, print datetime.now, but we can also pass it in the time zone that we want it in. So for that we have to import datetime, and also we have to import time zone from the datetime module. And what we're going to do is say timezone.utc. UTC is not actually a time zone, but it is the universal time standard. It is the central time, normally matching GMT, and it essentially allows everybody to talk about time with the same frame of reference. So somebody in America who talks about the time in UTC is going to be talking about the same time that I'm talking about when I talk about time in UTC. Even though it's not an actual time zone, no country follows UTC as a time zone. If we print this out, you'll see that the time is the same, but now we have what's called an aware object, a time zone aware object that says +00:00. What this means is that the current time in UTC is equal to the time in UTC with no offset. Okay, so the time here on the left is the UTC time, and now we have that the offset at where this time was taken is 0. So now we know it's a UTC time because the offset is 0. This time here was also a UTC time, but that's because my time zone right now also has an offset of 0, because right now I'm in GMT. And GMT also has an offset of 0 compared to UTC. However, if I did this in the summer, and I did this in the summer as well, these would be different. This would show 1 hour more or less. I can't remember exactly which way it goes, but it would show a different time because I would be in BST, because the UK changes time zone with daylight savings. So, why am I slowing down so much with this thing? It's really important that you get dates correct. Otherwise, your application is going to be showing your users times in the past or in the future. It's going to be really confusing. So what I normally recommend is your programs should always work with UTC times. Store UTC times in your database. Work with UTC times in your code. When a user gives you a time, like if you ask them, enter the current date, convert that to UTC and work with UTC. And you shall only convert it to a different time zone when you show the user the time. So if I go to America and I have this time stored, what I can do is I can say, this time was taken in a time zone +0. Let's convert it now to -7 when we go to someplace in America, subtract 7 hours from this, and now I can show this in their time zone. And the date and time will now match. So only when you show it to a user, which you must know their time zone in order to do that, of course, you convert it to their time zone. All the rest of the time, you're working with UTC, and that's just going to simplify things massively. Okay, so something else that you can do is, of course, you can do time deltas. Time delta. A time delta is just a difference in time. So you can say that, for example, today is daytime.now and timezone.utc, and tomorrow is today plus time delta days equal 1. What this does is it gets your current date and time, and it adds a time delta, which is a difference in time. The delta thing comes from mathematics. Essentially just means a difference in time, and the difference that you're applying, that you're adding, is 1 day, 24 hours. Okay? Now, of course, the time is going to be the same time tomorrow as it is today. So again, print today, print tomorrow, run this thing, show it to you, and we have 10th of February, 1551, 11th of February, 1551. So as you can see, same everything except for the day. Now, this leads nicely into the next thing. If you want to format the date and show it in a slightly nicer way, you can do that. So that's good. Normally, you'd see, of course, if you're in the UK, you'd see the day in front, then the month, and then the year. If you're in America, you would have a very weird way of doing things, and you'd show the month first. Or if you're Python, you show the day last, which is just... there's actually a reason for this, which is for sorting. The year goes first, then the month, and then the day for sorting. But of course, for readability, not so great. So what you can do is you can do print today.strftime. That means string format time. And inside the brackets, you give it the format that you want. So in my case, I'm going to do %d, %m, %y, big Y, that's important, %h, %m. %d tells the strftime function or method to print out the days. So that's going to be 10. %m, it says months. %big Y says the year as a 4-digit. %h gives you the hours, and %m gives you the minutes. So you can print this out, and you can see that you get now a nice format, where the day is in front, then the month, and then the year. 10th of February, 2018. The time is 15:53, and we have lost some precision there, but you can regain it if you want by adding %s there. You can see you get 40 now. You can also add in the milliseconds and the time zone information as well if you want. What's important to remember is that this printout here doesn't have the time zone information printed out, but the object itself still has the time zone information. Okay, we've not lost that. We've just not printed it out because the way we formatted the string matches this data that we've asked for. Okay, similarly, deleted that. You can ask the user for the date, like user date is input. Enter the date in YYYYMMDD format. And then you can convert it, datetime.strp time, in this case, user date, %y, %m, %d. Make sure to have a big Y there. And then you can print user date out. Let's print it out. I'll explain what it is in a moment. Now we can see that it asks us for a particular date, let's say 2010, 0505. And now we get 2010, 0505. 000000. We don't have time zone information in here either. So what's happened? We've asked the datetime module to call the strp time, which means string parse time. This is string format time. Parse time. Then we've put in our string that we want to parse. That's whatever the user entered, presumably in this format, YYYY-mm-dd. And then we've said, okay, and by the way, this string is going to be in this format, so now you can understand it. %y is 4-digit year, %m is 2-digit months, %d is 2-digit days. So now the strp time function has the date and its format, and it can join them together and give us a new datetime object that has the appropriate data in it. But of course, we've not given it the hours, minutes, or seconds, so all those default to 0. Okay. Notice how we don't have any time zone information there. We'll have to ask the user for time zone information separately, and we would have to include it in this parse string, or indeed if we wanted to print it out, we'd have to print it out down here. I can't remember from the top of my head exactly what percent it is. I think it's %Z, but I am going to include a PDF on date parsing and formatting, just these things here, what they mean, how you use them, attached to the resources section of this lecture. So don't go anywhere. Download that if you're keen on knowing a bit more about these dates, how you format them, and how you parse them. And yeah, I just wanted to tell you a bit about these date time module, some of the things you can do with it. Other thing you can do, by the way, time delta, you can have hours, you can have minutes, you can have seconds, you can have weeks in there. So there's a few things you can do in terms of adding time deltas there. You can, of course, subtract time deltas as well if you want. There's more to do with dates and times, but I cannot possibly cover all of the date time module without boring you to death, first of all, and also without some more specific use cases for these. So if you do have any questions about dates and times, ask away in the Slack channel, even if they're unrelated to the course. I'll be glad to help you out. And that's really the best way to continue going about it. As you have questions about date and time, find out, research through the Python official documentation, what other people ask in Slack and in Stack Overflow, and that's really going to give you any other tools that you need. But in terms of dealing with simple dates and times in your programs, this should be enough to get you started. You've got datetime objects, time deltas, and you know about time zones as well. And you also are able to format the time and parse any user input as well. So that's it for this video. I hope you've liked it, and I'll see you on the next one.
The darkness is spreading so fast these days. You must become a warrior of the light. And law says that what you're putting out is coming back all the time, regardless of whether you know it or acknowledge it or not.
Hi and welcome back. As well as the datetime module, used to deal with objects containing both a date and time, we also have a date module and a separate time module. They're used to deal with dates and times separately. In this video, we're going to look at how to time your functions, how long they take to run, using the time module. So how is that going to go? Well, it's going to be really straightforward. Before we run the code that we want to time, we're going to look at the current time. After we run the code, we will also look at the current time, which will be a few seconds or a few milliseconds later. And then we'll subtract one from the other, and that's going to give us the difference between the current time at the start and the current time at the end, and that's going to tell us how long the code took to run. Why might that be useful? Sometimes you won't know whether to use a specific code or something else because you don't know which one's faster if they both do the same thing. For example, should you use list comprehensions or list and map? We're going to look at that in this video. Let's have a look at an example. The first thing we're going to do is import the time module. This has a bunch of functions that you can use to deal with times. And now we're going to come up with a function that we will time. We will look at how long it takes to run. It's going to be a simple function that is called powers and takes in a single argument, which is going to be a number, and then returns a simple list comprehension that does something like this. So it gives you a new list where x is in range limit, so it goes from 0 up to whatever number we give it, and each number is turned to the power of 2. And so it just gives it a bit of calculation there. It's a pretty fast operation, it's really fast, but we can see how long it takes. Okay. Now, just to show you exactly how this works, we are going to print it out, just for you to know what it does. You can see here, it starts at 0, 0 to the power of 2 is 0, then it goes to 1, 1 to the power of 2 is 1, 2 to the power of 2 is 4, 3 to the power of 2 is 9, and so forth. Okay. Now, let's start by timing this function. The first thing to do is to get the current time before we run the function. So notice that up in here in line 6, we've not run the function yet, we've only defined it. So what we're going to do is we're going to say start is time.time. Time.time is, time module, and the time function within that module gives you the current time it gives you the current time since 1970. So it gives you the number of seconds that have passed since 1970, and that way you can look at essentially the current time. Now, it gives you it in seconds, but it also includes many decimal places to give you enough precision. So if this were to take only a couple of milliseconds or a couple of nanoseconds, you would still know. This is the current time at the start. Then we are going to do powers of, say, 50,000, 500,000? 500,000. Let's go 500,000. And then we are going to calculate the end time. And as you can see, it's exactly the same thing, but it's after the function has ran. So it gives us, essentially this can take some time, and then we're going to look at the end time after that has happened. Because remember, these statements happen one after the other. And then we're going to do print end minus start. Remember, end is going to be the larger number. That's the number of seconds passed since 1970. Start is going to be the smaller number because it happened earlier on. So this is going to give us a positive number, which is the difference between end and start. That is the number of seconds or milliseconds that this function here took to run. Okay. And I'm noticing that my notes actually has one less zero. So let's just try it with one less zero there in case we're going to be waiting here for a long time. Yep, that was a good shout, I think. As you can see, it's taking a little while to give it a go. And there you have it, 6.79 seconds. So, that tells you how long this list comprehension took to run, as well as, calling the function and so forth. It could be slightly, a few nanoseconds shorter if we didn't have a function, if we just did this in here. But, everything takes a little bit of time in Python and in any programming language, so that's just something that we have to deal with. Now, this is how you time your code, but of course, adding this start and end time before and after every piece of code you want to time can be a little bit cumbersome. So instead, we can turn it into a function. We can turn this stuff here, the measuring the start time and measuring the end time, into a sort of measure runtime function. That's what we're going to do in here. We're going to say measure runtime, and that is going to take another function that we want to measure. Okay. And we're going to start by looking at the current time, then we're going to run the function, and then we're going to look at the end time, and then we're going to print end minus start. Okay. So basically, we're taking all of this, and it's the same thing that we had down here, except now it's a bit more generic because we can pass in any function we want. Okay. And the function we're going to pass it in now is we're going to say measure runtime of lambda powers 50,000, 500,000. 500,000 is correct. Okay, so we've defined a lambda function, and when you call this function, it will execute the powers function with a given number. Notice that we've had to do it this way, passing a lambda function. We can't just pass the powers function there, although that would be nice, because then we have no way of passing the argument that it needs. So the lambda function allows us to do that. It now creates a function that has no arguments, but calls another function that does have arguments. So it's just an easier way to do this here. And again, if we run that, we get this here. I think I may have missed. I think we had a 0 more before. That's why it took so much less time. But that's fine. If we add one more, it'll take the 6.7 seconds-ish, around 6 seconds. And there we go, 7.4. This is just depending on the load that is currently in REPL-it, how much power they can give our program compared to other people's programs that are also running at the same time. Okay. So, just as a small aside here, this measure runtime function is, of course, a decorator, or a higher order function. And the powers function here is a first class function, because we're passing it in, or we could pass it in as an argument. Okay. Now, if we just wanted to time the execution of small code snippets, we can look into a separate module, which is the timeIt module. Okay, so we're going to import timeIt down here, and I'm just going to decrease this 0 again so we don't have to wait too long. We've got the timeIt module, and the timeIt module has a timeIt function inside it, to which you can pass a string. And this string has to be a Python statement that you want to time. So for example, we can take this thing here. Instead of limit, we'll just pass 10, and then it will tell you how long this takes to run. So it can be quite useful as well. Now, if we run this here, you can see that it's not instant, right? It's still loading even though the range only goes up to 10. And that's because the timeIt function actually runs this many times over, and then it gives you the total it took to do many iterations. So it can be useful because you now have a statement here that will not take a very long time to run, but the timeIt module is telling you sort of an average or a total across many iterations how long it's going to take. And that's precisely because if you only run it once and you wanted to compare it against something else, say for example the timeIt of list map lambda x to the power of 2 range 10. There we go. Say you wanted to compare these two. If you were just comparing this statement to the range of 10 against this one to the range of 10, they're both going to take so little time, 0.00000 something seconds, that you're not really going to have a very good comparison there. So by comparing across many thousands of iterations, you do get a slightly nicer comparison. Let's run that again. By the way, remember this is quite slow because RepelIt is not a very fast platform. It's not meant for performance, it's meant for functionality and letting you run this code on the cloud. So if you run this in your computer, it's probably going to be much faster. But we will see which one is better. And we're probably going to find that they're going to be more or less around the same. Maybe even map is going to be a little bit slower. Yeah, there you have it. Map's a little bit slower because you have to create the generator, you have to map over it, and then you have to turn everything into a list, whereas the list comprehension just creates you a list from the start. This does beg the question, which one to use? Should you not always use list comprehensions? They seem to be faster. And the answer is, if you want a list of things, use list comprehension. It's faster, I think it's more readable, it's certainly shorter, and there's no good reason why you shouldn't use it. But if you want to use the items of this list, these powers, one by one, then use map and use the generator it gives you. Don't turn it into a list. That way, you won't have to spend the time getting your full list in order. You can just use the items one by one as they are generated by the map function. So it just depends on how you're going to consume these things that you should decide which one to use. In addition, it's also a matter of readability. And as I said earlier, for me, the list comprehension is much more readable. So I would almost always go for that if given the choice. But some people prefer map because they're accustomed to doing that in other programming languages. So that's also a good reason to use maps instead of comprehensions. Anyway, that's it for this video. Just wanted to give you a quick rundown on how you can time your code and why you might want to do it. And hopefully this has been a nice experiment for you to look more into comprehensions and maps. So again, you can use a time module, calculate the starting and the end time for the thing you want to time. This can be useful in many scenarios and it's very flexible. Or if you want to time small snippets of code, you can use the timeIt module, and that can be also quick and easy. That's it for this video, and I'll see you on the next one.
Good girls don't make history. Bold girls make history. Bold people make history.
Hi Hi and welcome back. Let's talk about regular expressions. First thing and most important thing is that when we write regular expressions, we are writing with a language. Now, regular expressions are not a programming language, but there is still some syntax and some keywords that we have to know when we use regular expressions. And we use the syntax and the keywords to express what we want. So let's look at some examples of regular expressions so we know sort of what it is. Here's some text. And as you can see in this text, there are some patterns. You can probably spot this pattern. I think it's a reasonably straightforward pattern. You can see an A followed by a number, followed by a space, and that sort of repeats 5 times. You've got A number space, A number space, A number space, A number space, A number. Notice how there's no space at the end, so that's an interesting one. The other pattern that is there is this one. A1 space, A3 space, A9 spaces, A5 space, A4. So that's the entire string. So in regular expressions, we can use the language to define the patterns that we're looking for. So here we could define, let's look for a pattern which is an A followed by a number followed by a space. And the regular expression runners would then give us, hey, we found some instances of this pattern in this text. Okay. Let's look at another example. We're going to look just a couple examples of patterns so that you know sort of a bit of what we're looking for. Here's another pattern. We've got Jose, comma, space, Rolf, comma, space, Charlie, comma, space, Adam. So what I see here are some characters, like letters, followed by a comma, followed by a space. Okay, this is a pattern, potentially. Of course, the other pattern is the entire string again, but that's going to be the case for every instance. Let's look at this one. Here's some URLs, some addresses of the internet. And what I see are one of two things. The first one, I see a bunch of characters, followed by a new line character. Remember the \n that we've looked at before. So here the characters include letters, they include the dot, the colon, the forward slashes. You've got a bunch of characters there, and you've got a new line at the end. So that's one of the patterns I see in here. In the other pattern, where you analyze each line, you can see that every line is fairly similar to the line below. You have HTTP at the start. All of these patterns, all of these lines have HTTP at the start. Sometimes HTTP is followed by an S. In 3 of the cases, you've got HTTP followed by an S. And in all cases, that is then followed by colon, // Sometimes that is followed by www. And that is followed by some characters like Google, Facebook, Twitter, Udemy, Teclado Code. And finally, this is always followed by .com. So as you can see, this isn't a definition of all URLs, because some URLs, as you know, end in .net or in .me or in .it or whatever. This is just a definition of the patterns that we can see in the text that we're analyzing. So HTTP is always there. Sometimes you've got an S. Following either of those, you've got the colon //. Sometimes you've got www. In other cases, you just have the characters, and you always have .com. Here's one final example. You've got some emails. So what I see here is a combination of letters, numbers, periods, and underscores, which you can see, for example, Jose is a combination of letters. Rolf is a combination of letters. char.lee is a combination of letters and periods. Anna is a combination of letters. Gen45 is a combination of letters and numbers. And someone _is_awesome is a combination of letters and underscores. So you've got this combination of potentially different characters, and that's always followed by an @ symbol. As you can see, in all cases, no matter the combination, you end up having an @ symbol. And that's always followed by some characters, and it seems that those characters are always letters. You've got Teclado code, you've got Google, Twitter, Gmail, iCloud, and example. Those are followed by a dot, a period. You've got Teclado code, and then you've got dot, Google, and then you've got dot, Twitter, then you've got dot, and so forth. And finally, you have some characters. And it seems from this example that these characters are always going to be either com, me, or net. And then you end up with .com, .me, or .net. But, of course, we can be fairly smart, and we can say, it's possible that if we're looking at our emails, the characters at the end may be slightly different in some cases. We're not seeing them here, but, it could be different. Let's not say that it can only be com, me, and net. Maybe let's say that they can be any character. So, getting regex, regular expressions, is a matter of seeing the patterns, being able to identify the patterns, being able to look at a text and say, okay, these are the potential characters and symbols that I can see. This is the order that they're going to appear in them. And of course, you have to be able to express those patterns using the language. So that's what we're going to be learning in the next video. But I'll tell you there are 4 most important components in regex. You're going to be using these essentially all the time. First one is the dot. The dot means anything. Letters, numbers, symbols, anything you can think of except new lines. You remember the new line character, \n. The dot means anything except that. The plus symbol means one or more of. The asterisk means 0 or more of. And the question mark means 0 or 1 of. So let's analyze one expression using these pieces of syntax. Jose@tecladocode.com. You could say this is dot star. The dot means anything. The star means 0 or more of. So that's 0 or more of anything. Naturally, pretty much any pattern is going to match that, because you've got 0 or more of anything. That can be any character or symbol or anything else. So of course this pattern is going to match that. You've got dot plus. The plus means one or more of. So here you've got the dot. You have at least one character in the pattern, so it is going to match. You can also have something like Jose@tecladocode.com. So here you're matching the entire pattern, but of course you have to put a backslash in front of any symbol that means something in regular expressions. Otherwise it means anything. Like we know, the dot in a regular expression pattern means anything. So you have to put a backslash in front of it so it means the dot and not just any symbol. This is a bit abstract, so let's go to a better regex editor, and we're going to look at a bunch of examples in the next video so that you sort of start getting a bit more of an idea of how these regular expressions work. So with that said, I'll see you on the next video.
Life is an order, a discipline. Life is a focus, life is a purpose. Do not gamble on life. It may not happen twice.
Hi and welcome back. In this video we're going to be analyzing some regex expressions and having a look at a few more examples. If you can go to this website here, regexer.com, at least I think that's how you say it, could be totally wrong there. This is going to allow us to run some regex, try it out, and see how it works a bit better. So if this looks slightly different, don't worry, it sort of changes over time. It looks a bit different than the last time I used it. And what we're going to do is have a wee look at what is here. So I'm going to close that there. If you want to keep it open, you can do that by all means. You just click on this button here. You've got a few menu icons here. We're going to look at them just a bit later. But essentially what it says is Regexer is an online tool to learn, build, and test regular expressions. So it's a pretty useful thing. Then we have two main things. We have some text, and we have an expression. Don't worry about the things here, the //g and stuff like that, we will learn about those later on. So do not worry about them. Just, we're going to be typing our regular expressions within the brackets. You cannot type anywhere else. So it's going to be within the slashes, sorry. So in here, we're going to type our regular expressions. And in here, we're going to type the text against which they're going to match. So for example, let's say we are looking at this pattern that is Charlie. And we want to find out what regular expression matches this text, this word here. So we could do that. The first regular expression that matches the text is Charlie. So if you put the entire word Charlie in there, this shows you as a blue box that these two match. Down here in the tools section, it tells you exactly why it's matching. So you've got the character C, which matches the character C, the character H, which matches the character H, and so forth. Because you've got all these characters in this order, that matches exactly this word. Okay? But of course, this is too simple. So we can do something else. Notice that if you type the character C in here, you match only the C. If you only type the character H, you're matching only the H. You've essentially found, using this expression here, some text, or some pattern within this text. In this case, the pattern you're looking for is the letter H, and you have been able to find it. If you type P, notice how you don't get any blue boxes here, because the P does not match any word or any letter in here. Okay? So, the next thing we could do is we could type in one of our already known regular expressions, the dot. Notice that as soon as you type the dot, you get a lot of individual little boxes, one for each letter. That's because the dot matches any character except the new line or the line break. So what you've got is the dot matches the C, the dot matches the H, the dot matches the A, but it doesn't match the word because the dot only matches one character. If you wanted to match many characters, you would use, for example, the star. So you've got the dot star, which means any of or zero or more of the dot. And now notice how you get the box around the entire word. So what we've done here is we have now defined our regular expression pattern, which says that we want to match in our text anything and any amount of it. So it matches all our text. And indeed, if we add more text, notice how it keeps matching. It matches everything because the dot matches everything. But as soon as we put a new line in there, the new content is not matched because the new line character is not matched by the dot. So the dot is going to match from the start as much as possible until it reaches a character that it cannot match, and then it's going to signal the end of this pattern. Okay? The next thing we can match is some characters. So for example, once again, bringing the example of Charlie, notice how as soon as we type Charlie in here, we get Charlie matching. Nothing else matches, of course, because this is the only instance of Charlie we've got. Okay. We can do, for example, A, B, or C. So this is in square brackets, we've got A, B, C, and what this is doing is it's matching any of the characters inside the brackets. So as you can see, the character set here says it should match any character in the set. So you've got C matching, you've got A matching, you've got A matching there. If we add a B here, the B matches as well. So this is a range. And of course, now that we're matching A, B, or C, we can do, for example, a plus. And that is going to match one or more of this set. So if you have B, 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 you are now matching all of the B's as opposed to each one individually. Notice that if we remove the plus, they now match, but they match individually as opposed to all together. When you add the plus, they match all together as a single thing. Okay? Instead of A, B, C, we can select all of the letters from A to C. And notice how now you match on all the letters except the capital letters. And I'm going to delete these B's there. You match all the letters, you don't match the spaces, you don't match the capital letters. Notice how the letters all match individually. If you add A to Z plus, or A to Z plus, depending on where you're from, now you see the words start matching on their own. Or at least the parts of the words here start matching on their own. So that's pretty cool. Because now, if we were to run this regular expression using Python, we could extract each word in our text, which is quite nice. If you wanted to match the capital letters as well, you can do that by just using a capital A there. Now you're matching the capital letters as well, and you're matching the whole words. What this is doing is this is a range. So you're matching letters that go from the capital A to lowercase z. Notice how down here it tells you that these character codes are from 65 to 122. So these are ASCII character codes. It just means that you're matching all the letters in that range. So that's A to Z, or A to Z in lowercase, and also A to Z in uppercase. Okay. So here's another example. If you type Jose, A to Z plus matches the entire word. A to Z alone matches each character individually. And if you put a dot in the middle, you are matching JO and SE, but you're not matching the dot. Okay? Of course, if you then put the dot in here, remember backslash dot, now you are matching anything in that range, or this dot, any number of that. So remember, the square brackets are a character set, so you're matching any character inside the square brackets. This is a range of characters, so it matches A, B, C, D, E, F, G, blah, 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 up to the Z. And this matches the dot, and you're matching any number of them. If you put the dot in here without the backslash, you're matching anything. So you no longer need these things. Okay? Let's do that. Cool. Let's look again at the emails. Let's look at, for example, jose@tecladocode.com. Notice how A to Z backslash dot plus matches the Jose, because that is 4 characters in this range. And it matches tecladocode.com, because it's, again, any characters in this range. But it does not match the @ symbol. So, of course, we could fix it. We could say A to Z plus, and then the @ symbol. Because now we've got any character in here, A to Z or the dot, any number of those, and then an @ symbol. But notice how now we're only matching Jose @ because that's the only thing that matches this. If we put an @ symbol here, now it matches the entire thing, because A to Z and the dot matches this. The new @ symbol has to match too. So what can we do instead of that? Well, we can add some more ranges here, A to Z plus, and now we're matching Jose @ tecladocode, because we've got our first letter range here, the plus, which says more than 1, the @ symbol, which matches exactly this @ symbol, and then we've got another range with a plus that matches another number of characters here, but then we don't match this dot. If we wanted to match the dot, we would have to add the dot in there, and now it matches everything. Okay. Now, if we wanted to only match some of these TLDs, like for example .com or .net, we could do that, but then we will have to restructure our regular expression slightly. Instead of doing that, we could do this. Now the dot is outside this range, so it's only included once, and as soon as we reach that, we stop because this dot is outside the range. So again, what we're matching is A to Z or any dots, any number of times. That's Jose. We've got the @ symbol, which matches the @ symbol. A to Z plus, which matches any number of letters. That's the teclado code. And then we've got this dot, which matches the dot. Now we have to decide how to match the .com. So we can put a com, and that will match, of course, because we've got com there. Or we can do, for example, com / or pipe me. So then it'll match .com, but it will also match .me. But it won't match .net, for example. Notice how now nothing matches in this pattern. This pattern does not match this at all. As soon as we change it to me, though, it does match, because now Jose is here, @ symbol is there, teclado code is there, the dot is there, and the me is here. So what the pipe means is either of these two. And what the bracket means, it just allows you to capture things and combine them together. Okay. So there's a lot more to regular expressions than this. There are ways to match numbers, there's ways to match addresses, there can be some really long and complicated regular expressions. And I'd encourage you to play around with this website, try a few things out, and also if you look at the menu, you've got here a reference. This can tell you a bit more about the different things that you can use in regular expressions. And also there's a cheat sheet that tells you a bit more information about regular expressions. Regular expressions would take a few hours to cover comprehensively, so it's not something that I think we want to get into. But of course, if you have any questions or you want to match any specific patterns and you don't know how, by all means go ahead and ask in the course Q&A or in the Slack channel, and I'll be more than happy to help you. As we progress through the course, we're going to be using some more regular expressions, and when we do that, we will look into them. But I just don't want to turn this into a course for you to learn all about regular expressions, because I think that could be quite boring for some people who just want to continue and do some programming. Again, any questions, please come and ask me. I'll be more than happy to help. But other than that, let's move on. We've understood a bit of what regular expressions are about. We can now start using them and really understand them when we do that. I'll see you in the next video.
I believe strongly that just don't go through life, grow through life. And I'm sure there is always room for improvement and things will get better and better and better.
Hi, welcome back. We've just looked at some regular expression examples. We've not gone very in depth, but as we progress through this section, we're going to learn a little bit more about it. And as we do more Python and we encounter more uses for regular expressions, we're going to learn some more. Regular expressions is one of those things that you use it, you learn about it, and then you just don't find any use for it for a while, and then you just sort of forget, and then you have to go back and learn it again. So it's not that great if I just spend a few hours teaching you all there is to know about regular expressions. I think you'll forget quickly, and I don't think it'll bring you that much benefit. When you want to use regular expressions within Python, you can do that. You can import the RE module. RE stands for regular expressions, and it comes with Python, and it lets you test an expression against some text. That's essentially what we did in the last video. So this will be our text. It'll be an email. And this will be our expression that we are testing. A to Z plus. What is this going to match? The A to Z plus would match the Jose, it would match the teclado code, and it would match the com. Because there are three separate words in here, and the A to Z plus, what it's measuring is, or what it's testing is, any letter, at least one, and as many as possible. Okay? So what we'll do is we'll say matches is re.findAll expression on email. What that's going to do is it's going to take this expression and it's going to try to find all the instances in which it occurs. So it's going to find three: Jose, teclado code, and com. Okay? Let's print out the matches. Then we're going to say a couple of things here. Let's run it first. Notice how our matches are now turned into a list of Jose, teclado code, and com. So that's all the matches that we found in this expression here. So that's pretty cool. As we can see, the name is matches 0. That's my name. And the domain, tecladocode.com, could be made up of matches 1 dot matches 2. Like so. So that's tecladocode, that's the dot, and that's the com. So in total, we make up tecladocode.com, but of course this is wrong because it has to be like that. My bad. It has to be like that. So then we can print the name, we can print the domain. Let's run that. And you'll see that this all seems fine. We've got Jose and we've got tecladocode.com. Now, a better way of extracting the name and the domain would be to modify this expression in order to make it A to Z and include the dot. Because now there are two matches. Jose, because that matches 4 characters in this range, so you've got A to Z or the dot, and you've got 4 or 1 or more of those, and you have 4 characters. And you've got tecladocode.com because that matches a character or a dot many times, and you've got there a lot of matches. So now you're going to have 2 matches, Jose and tecladocode.com. So the domain is going to be matches 1. Let's have a look. And there you have it. So you've got now 2 matches, Jose and tecladocode.com. Jose is the first match, tecladocode.com is the second match. Of course, if you did want to do that, if you wanted to extract the domain of an email, the best thing you can do is you can not do any of that, and instead you can have your email here. And you can have something like parts is email.split on the @ symbol. We've looked at the split method before. That does exactly what we need. So you don't need regular expressions for this at all. So again, the name would be parts 0. The domain would be parts 1 in this case. And you could print them out. So in some cases, you won't need regular expressions at all. And it's important to recognize those instances. If you just wanted to get the name and the domain of an email, you don't need regex. You can just do it with Python. Here's a slightly more contrived example, introducing a couple of new concepts that we didn't look at in the last video. So we're going to import RE for the regular expression module, and then this is going to be our text. Price is $189.50. So what's our expression going to be? Well, I'll let you think about that for a wee bit, and I'm just going to check our matches here. And notice how I'm now doing re.search. What this is going to do is it's going to do something slightly different. I'll tell you in just a moment what it's doing. So let's say that our regular expression is going to be 189.50. What do you think we're going to find? Let's run this. And notice how now we get 189.50 as matches.group 0, and we get an index error, no such group, as the second group. Okay, so something's going on here. It's only able to get one group. So presumably, group 0 is the thing that's matched. And that would be correct. But now I'm going to modify my expression slightly to include the price. And let's include the $sign here. But actually this pattern here is not going to match this text because the dollar means something in regular expressions. So we have to put a backslash in front to make sure that this gets treated as the $sign and not as what it means in regular expressions. So let's press run. Now notice how we can see that the entire thing is the group 0. Price, space, dollar, 189.50. Now I'm going to do something that is going to be a bit weird, but I'm going to put some brackets in here around the 189.50. So I've just put some brackets, and that's it. Now let's run it again. Notice how now we don't get an error. We get price is $189.50. And now the group 1 is $189.50. So this is important. This is really useful in Python, because what we've done is that we have evaluated this pattern against the price. That's what re.search does. But then it has allowed us to extract particular parts of that by using the brackets into group 1. So group 0 is the entire match. Group 1 is the first thing in brackets. So why is this useful? It's useful because now instead of 189.50, we can say, for example, 0 to 9 dot plus. We can put a backslash in this dot since it's meant to be not anything but rather the dot. 0 to 9 dot plus. Sorry, just a plus, not the dot plus. My bad. So what we've got now is any of these characters, 0 to 9, and any amount of them, followed by the period which separates numbers from their decimal place, followed by 0 to 9, any number of characters. So this could potentially be, for example, this, right? Any number of characters, any number of numbers, followed by any number of numbers with a full stop in the middle. So this can match any number. The great thing is now whatever this price thing here is, for example, let's say we change it to $18,000, we're going to match it here, and when we run, you see that what we have extracted is the number. So why is this great? It's great because we can say that price or price number is a float of matches.group1. So let's run that. Print price number. Notice how now we get a third thing printed out here, 18,649.5. So essentially what we've done is we've turned this incomprehensible piece of text and we have extracted a Python number from it. Just imagine you were extracting some data from a website, like we're going to be doing very soon, and you want to extract the price of something. You need to be able to get it out of the text. And really the only way to do that reliably is by using regular expressions. Okay. What about if we do like a comma after the thousands, like a lot of countries do? Well, it's pretty simple. 0 to 9, and you include a comma in there. So now this is going to match any number of characters, of digits, or a comma, any number of times. So any character from 0 to 9, or the comma, any number of times. I actually don't think we need the backslash here, because I don't think the comma is anything in regular expressions, so it doesn't need a backslash. Okay, so now we run it again. Now, the first group here, group 1, was this 18,649.50, but then we got an error because we cannot convert 18,000 with a comma in there to a float, because Python doesn't know what the comma means. So what we have to do is, of course, say price without comma is this matches.group1, but then this is a string, remind you. We're going to call a method of the string that is a very useful method, that is the dot replace method. And what we're going to do is we are going to replace the comma by an empty string. That's essentially just going to remove the comma. And now we can turn a float of price without comma. Let's run this again. And notice how now we get our float back here. Full Python float. We can add it, subtract it, multiply it, anything you want, because now we have the actual price as a number, not as a string. So potentially, let's say you were getting some data from Craigslist or something like that. You could look at the websites with Python, you could download them, you could load the price, you could convert it to a float, and then you could compare it against, say, your budget or the hourly rate that you want for your job or whatever it is that you're searching for in Craigslist. Craigslist, by the way, if you are not in the United States, is a classified ads website, like Gumtree in the UK. So it's pretty useful to be able to extract meaningful information from text. That's what regular expressions do best. So again, we've looked at a few examples of how you can use the RE module to search through regular expressions. As we do more and as we require the regular expressions module, we're going to learn more about it. I don't want to delve too deep into it without a use case because I think that's going to just be a bit confusing and a bit pointless. So let's wait until we have a better use case. But in the meantime, I would recommend that you take the time to look through the Regex website if you want, and the official Python documentation for the RE module, as it's quite good. And the code that we've looked at in this section, everything we've written, as well as a couple of links to the other sites are going to be included in the resources section of this lecture, so feel free to have a look if you're interested. That's it for this video though, and I'll see you on the next one.
Do not compare yourself to anyone's life that you see on social media because you're seeing the showreel of highlights. Whether you call it a highlight or a carefully cultivated, showreel of how their life looks. You're not seeing the behind the scenes. You're not seeing the other moments.
Hi and welcome back. In this video, let's talk about Python logging. In the simplest terms, the logging module is used to print things out. Very much like the print function that you've used before, but the logging module is a bit more powerful. It can be used to print things out to a console or to a file. And essentially it's used to print out logs. I don't know if we've mentioned logs before, but a log is essentially everything that happened in your application. For example, you could have a log of your day in which you write down in some sort of notebook everything that happened in your day. You could have a log of a holiday in which you write down everything that happened during your holiday. And you could have a log of your app, in which you write down everything that happened during your app's runtime. For example, whether an error happened, a critical problem, some information about some method that's running, basically anything. And these logs are used for developers to look into to understand how the applications are running. Of course, if you have a very small app, it's maybe not so useful. As your app starts growing, having some decent logging in there is going to be very handy. The good thing about the logging module is, one of the good things about the logging module is that it has various levels of logging, and you can sort of enable some levels and disable others. So for example, as you are developing, you may want to use the logger to output informative messages about what's happening in your application. Once you deploy your application, you share it with your users, and it's running, and you've got a lot of people using it, maybe you don't want informative messages, you only want messages that are related to errors. So with a logging module, you can do that. If you've got print statements everywhere, you cannot enable some and disable others. So the logging module, pretty cool. We can import logging. And the first thing we have to do is we have to get a new logger. So we're going to create a variable logger, and it's going to be logging.getLogger. And then we have to give it the name of the logger we want. So we're going to call it test logger. The good thing about this is that it's meant to be used across multiple files. So if you have a logger called test logger, and you call this from a different file entirely, it's actually going to give you the same object. And that's good because you can configure loggers to print things out differently. You can configure loggers to export to a file or to the console. So it's quite nice that you can do this so that when you get the same logger from a different file, it will be configured the same way. We're going to look at configuring them in a moment. Then it's very simple. When you want to print things out, all you do is you say logger.info, for example, and this will not show up. Or you can do something like logger warning, and this will. Then you can run it. And as you can see, you get warning, test logger, this will. Your informative message did not show up because by default, all loggers are configured so that they only show messages warning and above. So here are the levels that you've got. You've got debug, that's the lowest level. You've got info, that's the level above. And these two don't show up by default on new loggers. You have to say, I want these in order for them to show. The next one up is warning. These ones do show, as you can see, our warning message, they show up. Then you've got error, and then you've got critical. Critical is the most critical one, of course, is the sort of most important. Debug is meant to only be used while you are developing the application. Okay, so again, use the debug level if you are developing or debugging, and basically things you don't want users, well, none of these are for users, but basically things that you only want to see while you are developing, not while your application is running for your users. And of course, if your program's about to crash because you found some critical exception or something, you can use logger.critical. The way you configure your logger is that just before you create it, you must say logging.basicconfig. And in here you can say level equal logging.debug in uppercase here, or .info if that's the minimum one you want to show, .debug if debug is the minimum level you want to show. However, this doesn't quite work in REPL-it. So let's go over to PyCharm to give this a go. I've moved over to PyCharm now and I've just copied the code. So again, we have import logging, logging.basicconfig, where the level that we're going to show is at least debug. Then we've created our logger by calling logging.getLogger. And then we've printed out two messages, one that says this will not show up, and one that says this will. So let's run the app. And you can see that we get now the info message there as well. I think this is because the test logger here actually inherits from what's called a root logger. And I think that REPL-it has configured their root logger so that debug and info messages do not show up. So that's why that may not work in REPL-it for you, but it will most definitely work in PyCharm since you have control of everything. REPL-it is, after all, running the Python in their own environment, so they also have some of their own configurations there as well. Okay. Now, you can configure the output to show a bit more info, rather than just the level and the logger that printed things out. In basic config, you can have something like format, and then in a string, you can put whatever it is that you want to format your log messages as. So for example, ask time s. This is, by the way, old school Python syntax for string formatting, and it's going to use the ask time variable that will be available when this gets used. The s means turn it to a string. So ask time s, for example, percent level name s, and then percent message s. So this thing here is going to look pretty similar to our existing message, but ask time is actually going to print out the time at which the log was printed out, instead of the level. The level name is going to be printed out here, so what we're not going to print out is the name of the logger. If we run the app, you'll see that now we get the time at which we printed out, the level info, and then the message. I think this is slightly nicer, because now if you have a larger app and you've got a lot of logs sort of appearing, you'll be able to tell when each log happened. Then if you're looking back, you'll be able to see sort of, yeah, I logged this message at this point in time, and then I logged this message, and then an error happened. So you can then sort of reconstruct from these logs what happened in your application. Okay. If you want to configure your logger for sort of maximum readability, I've got an example that I think is pretty good. It's taken from Stack Overflow, but I think it's good. I'll paste it in here just for you, and I'll explain what it does. This here prints out the time, as you know. This prints out the level, but the level name is actually formatted as 8 spaces. So, for example, you have down here info that takes up 4 spaces. What the -8s is going to add 4 spaces after it. That way, all of your levels are going to take up the same amount of room, and your log messages are going to appear sort of one beside the other. Then, inside square brackets, these are just good old normal square brackets, we're going to print out the file name in which the log was printed out, and the line number as a number. That's what the D means. And then we're going to print out the message finally. So let's run this again, and now you'll see that this is quite readable and also quite useful. You're getting the time and what type of message it is. You're also getting where the message was logged, and this is fantastic. This is really why logging is brilliant, because you can see exactly where things happened. And finally, you can see your message there. Notice how it's quite readable. So I like this example here. Feel free to use this in your logging, of course, as you choose. Now I'll give you some other examples of a debug message. This is a debug message. You can do, of course, logger.critical. A critical error occurred. You can log these out, and as you can see, they'll all appear, and they'll all take up 8 spaces, because critical is the longest one, and that takes up 8 characters. And so this is pretty handy. Okay. Now, you can also log to a file instead of to the console. We're going to look at how to do that in the very next video. I'll just quickly show you. And this is how you do logs in Python. You'll see many large Python apps using this exactly, this logger, and it's really that simple. You just get a logger, you call it whatever you want. Normally it's related to your app or sort of to the part of your app that you're working with, and then you can log out messages. You normally see a lot of these messages being logged, because then you can choose to only show like error and critical in some cases, and all the way down from debug when you are working. So it's really quite nice. It's very flexible. Definitely recommend doing this. Do keep using print when you want to communicate with your users. Don't use logs to communicate with your users. They'll be very confused. So do keep using print if you want to talk to your users. The logs should be something completely separate, and they should normally go to a file or something like that. We're going to look at how to do that in just a moment. Okay, so that's it for this video. I'll see you in the very next one.
Don't try to be the best. Be the first. Be the first to change. Be the first to take the challenge.
Hi and welcome back. I wanted to tell you in this video how to log to a file, and also a couple of things about the structure of these loggers. In order to log to a file, it's really straightforward. All you have to do is in this basic config here, add another argument called file name. And this can be, for example, logs.txt. Very simple. You do this, you run your app, and then you see logs.txt appear, and it contains your logs. So when you're logging in your application, definitely recommended to log to a separate file. So that main thing is so that your users won't be able to see your logs, and also so you keep your logs in order that you can then review them later on. This is particularly important when we're developing web applications and things like that are running for a long period of time, and you need the logs in order to be able to track down problems. We're going to look at web application development in a later section, so this is why I'm mentioning this now. The next thing I wanted to say is real quick how these loggers are structured. Here we've got something called the test logger, but normally you would call this something like __name __. That's just so each module has its own separate logger, and you have a bit more sort of flexibility with how the loggers operate. However, it's also very popular for you to call your logger something like, for example, let's say this app did something like book handling or something. You call this logger books, for example. And then it's fairly popular that when you go into a different part of your application, you will get another logger and call it like books.database, for example. Let's say you are in the database file down here, and you're in a new file called the database.py or something, and you want to get a different logger for logs related to a database. When you do books.database, this is actually a child logger, so you get another logger which is a child logger of books. Any configuration you've got on the books logger will be inherited by the database logger, or the books.database logger. So it's normal to structure these loggers like that, and sometimes you end up with some fairly long logger names. That's totally fine. But again, it's also very popular to call them as __name __, and then they get called after the module that they're currently operating in, or indeed the import path, as you know. So either very popular, And I'll just mention quickly that there is more on loggers than I've covered. And there are things like handlers and things like that you can look into. But to be honest, this is plenty for the applications that we'll be building, and indeed for more advanced applications, and indeed for professional applications as well. You've got some more advanced functionality, but I've not used it that often. One more thing that I'll just say right now as well. If you want to format the time in a particular way, you can do that. You can do date format equal. And in here, you can enter formats like you would with the string format time method, strf time. So you can do -d, -m, -y, %h, %m, %s, for example. And then this will be formatted slightly differently. If we look at the logs now, you can see that these old ones have the complete date, including the milliseconds there, and these ones are a bit more reasonable. Also notice that when you run your app multiple times, the logs do not get lost. And so the logs just get appended to. And that's a pretty nice feature too, just in case your app crashes or something, and then it restarts automatically, like we will do in the future. Your logs are not going to get lost because of that. However, of course, the file can grow pretty large, so that's something you have to take into consideration. Alright, that's it for this video. Now you can use logging in your apps. And honestly, you don't need anything else. As you learn more Python and as you work with other people, you may encounter some situations where you'll use some other feature of the logging module. But honestly, I've not had that situation yet. So that's it for this video, and I'll see you on the next one.
Don't worry about people who are trolling you for your looks. One day, a big Hollywood hero will call you sexy Tamil friend.
Hi guys, and welcome back. In this video, we're going to learn about higher order functions. These are functions that accept other functions as parameters and run them inside of their own body. So let's get to it. Let me define a simple greet function that just prints hello. So here we've got that. And now you know, of course, that we can refer to this function by name. And we've learned about this much earlier on in the course when we learned about first-class functions. The greet function can be assigned to a variable, for example, if we wanted. And at that time, we mentioned that we could pass them in as arguments to other functions. So let me just real quick create a function that will accept another function as an argument. So here I've created this function called before and after. It has a parameter, func. And remember, this parameter can be anything you like. The name, func, suggests that this is going to be a function, but you could pass in whatever you want. There is no compulsory value for parameters in Python. However, let's say we print before, and then we're going to use this parameter as if it were a function. So we'll say func, and then we'll put the brackets behind its name, and you know that this runs a function. When we do this, if we pass in any value that is not a function, we're going to find an error when we try calling it as a function. Now I'm going to also print after, so that we can see how this works. Okay, so if I do before and after, and I pass in the value 5, I told you we're going to get an error. And the error we get is 5 is not callable, or int object is not callable. We tried to do 5 and put the brackets after it. You can't do that in Python because Python doesn't know what to do with something that is not a function when you try to put the brackets behind it and call it. So instead we have to pass in a function. So let's say that we get lambda 5. So a simple lambda function that doesn't have any parameters because there's nothing before the colon, and it just returns the value 5. Now we get before and after. Notice that 5 was not printed out because here we're running the function that just returns 5, but we're never printing the value out. So we would have to print if we want to actually show the number 5 in there. Okay, so this is how a higher order function works, essentially. It takes in a function as an argument, and then it can run it inside the body, and that's really it. Notice that if we wanted to pass in the greet function, we'll just pass it by name. We would not run the function, because as soon as you run the function, that's going to return the return value of this function, which is none, and it's going to pass none as the value to func. Then you're going to try to run none as if it were a function, and you're going to get an error. None type is not callable, and that's what you get indeed. So you want to pass in the function name so that you can run it when it gets there. All right, let's take a look at another example. Here we've got some movies in a list of dictionaries. Each dictionary has the name and director of the movie. We're going to write a piece of code that allows us to find a movie, but we're not going to define in our code how we're going to search for the movie. So we'll ask the user whether they want to search by name or by director, and then we're going to use that together with a higher order function to find movies. So how is that going to go? Well, we're going to do find by, and that's going to be an input of what property are we searching by. And this is going to be either name or director. We're going to ask the user what sort of thing they're searching by. Then we're going to define a looking for variable that is going to be what are you looking for. And this is going to be the value that should match this property. For example, they might enter name in here and then Klaus in here, and our code is going to go through these movies and find this one because the name property that they entered matches the value that they were looking for. So how do we do this? Well, first of all, we need to define a find movie function. And this function is going to have some piece of code that it runs to determine whether we are looking for the name or the director. So we're going to call that finder. What this is going to do is it's going to go through the movies for movie in movies, and we're going to print finder of movie. Okay, so just building this out in front of you to show you where my thoughts are with this function, find movie. What we're going to do is we're going to say find movie, and then in here, we're going to pass in a function that this function can run to retrieve a particular piece of data from this dictionary. So what we'll do is we'll say lambda movie find by. Okay, so this lambda function here, it takes in an argument and it returns the find by property of that argument, assuming that the movie is a dictionary. So for example, if find by was name, then it would return movie name, where movie is any arbitrary argument. So let's say that we have this function passed in to the find movie function, and we run it on the first movie. So we'll pass in this dictionary here to the finder function, which means this dictionary will become the movie parameter. Then we will get the name property of that movie, giving us the matrix. So I know this is quite complicated, but if you do this without higher order functions and first class functions, it becomes a bit more difficult to do, in fact. So let's run this. And now we're going to type in name, and then we're going to type the matrix. It doesn't really matter. It's going to go through all the movies and print out the name. Because what it's doing here is it's accessing the finder function for each movie, basically. All right, now we have to pass in as well what value we're looking for. And I'm going to pass that in first, just because that feels a bit more natural to me. And I'm going to call that the expected value that we expect to find in the movies. Now we'll say that if finder of movie is equal to the expected value, then we will essentially return movie. Okay, now we can say movie is that, and we will print movie. So now what property are we searching for? Let's say director. What are we looking for? Pablos. And there we have the Klaus movie being returned to us. I'd really recommend typing this code out, playing around with it, modifying things and seeing how it works. Ask questions in the course Q&A if you have any. But essentially, this is what is allowing us in just a few lines to create this search function. Now, something else we can do is we can do movie or no movies found. And that is going to run, and let's say we're searching by name and we are looking for 1918, which is not a movie. We get no movies found. If we'd put 1917 there, we would have found the right movie. Another further improvement that we could make to our find movie function is we could create a found list, and instead of returning a single movie, we could do found.append movie, and then in here we could return found. That way we can find multiple movies with the same name or director, for example. Of course, we would have to rename this to movies, since that is now a list, but you get the gist of it. Alright, this is one example where higher order functions can be useful, and there's a lot more. We use them extensively in decorators, for example. We'll learn more about those later on in this course. But just remember that you can pass in functions to other functions, and you can run them or not. You can potentially create some function that only runs the argument depending on some